Hello, Mr. Zonker here, and today we're going to be doing some operations with complex numbers. Let's start with basic addition and subtraction. Now remember, your complex numbers can be treated just like terms. So in this one we would have 2 plus 1, that would give us 3, and our other like terms are our i's, that would be 3i minus I, that would give us 2i. So we have 3 plus 2i would be the answer to this one on the left. Let's look at the next one. 3i minus 1 minus 2 minus 3i. Now remember, this minus has to distribute across the parentheses. So this is going to change to 3i minus 1 minus 2 and minus negative 3i is going to change to a positive 3i. And now we can combine our like terms. So we've got 3i plus 3i. That gives us 6i. And then we've got negative 1 minus 2. So we get 6i minus 3. Moving on to multiplication. Here we have parentheses 2 plus I times parentheses 3 minus 2i. Now remember, when we have these parentheses next to each other, we have to distribute each term. Some of you like to call it foiling. Here we're going to do 2 times the 3, which gives us 6. Next we're going to do 2 times negative 2i, which is going to give us negative 4i. Next we're going to do this I times 3, which is going to give us positive 3i. And lastly, we have I times negative 2i, which is going to give us negative 2i squared. Now, keep in mind we have this I squared here. We know I squared is equivalent to negative 1. So I'm going to go ahead and replace that I squared with a negative 1. And I'm going to continue on with my problem here. So I have 6 minus 4i plus 3i. Now, here I have negative 2 times negative 1. I'm going to get rid of my parentheses first. That's going to give me 6 minus 4i plus 3i plus 2, because negative 2 times negative 1 is positive 2. Now I can combine my like terms. I get 6, the 6 and the 2. That will give me 8. And then I have negative 4i plus 3i. That'll give me a negative 1i. And here's my answer. Okay, I pushed all that to the side so we can do our next one. 1 plus 2i squared. Now, be careful not to make the mistake where people distribute the square to give them 1 squared plus 2i squared. That is incorrect. We need to square the entire parentheses. And remember, that's going to give us 1 plus 2i times 1 plus 2i. Then we're going to distribute just like we did before. This is going to give us 1 times 1 is 1. We have 1 times 2i is 2i. We've got 2i times 1 is another 2i. And we have 2i times 2i, which gives us 4i squared. Now if I simplify further, I'm going to get 1 plus my 2i's combined to give me a 4i plus 4 times I squared. Remember, I squared is negative 1. This is going to become a negative 4. And my final answer is going to be 1 minus 4, which is negative 3 plus 4i. Moving forward, let's look at a new concept called the conjugate. And we're just going to do some quick practice showing you how to find the conjugate and what it does. Then we're going to see how it helps us to simplify problems. But for now, think of the conjugate as an easy way to take out your i's. Here we have 3i. The conjugate is always going to be the opposite. By that I mean we have a positive 3i here. This we're going to multiply by a negative 3i. Now if we did 3i times negative 3i, that'll give us 3 times negative 3 is negative 9. I times I is I squared. Remember, this I squared is going to become a negative 1. And this is going to simplify to a positive 9. Notice we eliminated the I. Let's take a look at this 3 plus I down here. Here we have 3 plus I. The conjugate is going to be the opposite, 3 minus I. Now if we distribute this out, we'll get 3 times 3 is 9, 3 times negative I is minus 3i times 3 is plus 3i, and then plus I times negative I is negative I squared. And remember, this negative I squared is going to become, this I squared is going to become a negative 1, so overall this is going to become a positive 1. Let's go ahead and combine our like terms. 9 plus 1 is 10. And negative 3 plus 3i, those cancel out. And we're just left with 10. Notice our I was eliminated there as well. We're headed into the lightning round. Quickly identify the conjugate for each of the given expressions. Here we have I. The opposite of that is going to be negative I. Here we have 2 plus I. The opposite of that is going to be 2 minus I. Here we have 3 minus 4i. The opposite of that is 3 plus 4i. Here we have negative 6i. The opposite of that is positive 6i. Got the hang of it? Awesome. Let's see how we can simplify some problems. When dealing with complex numbers, you always want to eliminate the I from the denominator. So, to remove I from the denominator, multiply the top and bottom by the conjugate of the denominator. Let's take a look at this example here. I notice the denominator is 3i. My conjugate for 3i is going to be negative 3i. So this is what I'm going to be multiplying to the top and bottom. So here I multiply the top, negative 3i. I multiply the bottom by negative 3i. Be very careful when you're dealing with the numerator. This negative 3i is going to have to distribute to each of these terms. So I personally like to draw parentheses around the numerator and the denominator, so I always remember to distribute if I have to. So let's start with the numerator. Here I have negative 3i times I. That's going to give me a negative 3i squared. Next, I've got a negative 3i times negative 2. That's going to give me a positive 6i. Moving down to the denominator here, I'm going to have 3i times negative 3i. That's going to give me negative 9i squared. Let's keep moving forward. We know this I squared on top is going to become a negative 1. So this is going to become negative 3 times negative 1 plus 6i. We know this I squared on the denominator is going to become a negative 1 also. That's going to become negative 1. Now if I want to simplify this, finally I have negative 3 times negative 1 is positive 3. I'm left with this plus 6i. And in the denominator, we notice our conjugate worked. We have no more I down there, and we just are left with negative 9 times negative 1, which is a positive 9. For further simplification purposes, let's go ahead and rewrite this big fraction as the sum of two different fractions. We can split this up to 3 over 9 plus 6i over 9. Notice if we went backwards, these have common denominators, so you could just add the numerators and it would bring us right back up to here. But since we're simplifying, let's split these up. So that's just going to be 3 over 9 plus 6i over 9, which we have down here. Now I notice this 3, 9 can simplify to 1/3. I notice this 6 over 9. 3 goes into both of those, and I can simplify that to 2i over 3. And this is going to be our simplified answer.